Hello and welcome. You are looking at constructing parallel and perpendicular lines. Now, if you have not done this before, or if you have not seen my previous video on basic constructions regarding constructing congruent segments, congruent angles, perpendicular bisectors, and angle bisectors, though we won't be doing it here, I recommend you watch it and check it out. This is how you use the compass with it, and although there will be steps that will be written to talk about how to do that kind of stuff, I won't be spending a lot of time talking about those portions. I'm going to be talking about the parallel and perpendicular stuff for the most part. All right, I'm going to start by talking about this compass here, right here. This guy. It's a geometric tool used to draw a circle or arcs. So for instance, an arc looks like that. A circle can be significantly bigger. It can be the entire thing right there based on a preset radius. So I can change this width of this guy here. I could make another one. And you can see that that middle part, that pivot there, is called, well, it's called a pivot. But here, when I draw the circles, it's called a center. Right? So that's kind of how that works, and it makes a lot of sense. I'm mostly just going to be drawing arcs, though, just little bits like that. Because I'm going to be making intersection points. I'm going to draw lines through it. No measurement is involved in this whatsoever. Everything except for making sure that this stays the same width. But I'm not using values in any sort of way. I know this has values here to show the width. But that's it. When accompanied with a straight edge, one can use certain reference points in order to construct parallel lines, lines perpendicular to a line through a point on the line and through a point not on the line. You'll see both of them, and special quadrilaterals. So we'll get a look at that as well. Let's start off with parallel lines. What I'm going to do here is I have a line way down here. And what I'm going to do is make a line that's parallel to it. Now, obviously, in my software, I can just copy and paste, but I'm not going to do exactly that. I'm going to begin with a line segment of any length. There it is. Now I'm going to draw another line through it similar to a transversal. So if you know that, like here, I'll start with two parallel lines right now. If you've seen a transversal before, it looks like that. Here are two parallel lines and a transversal that runs through it. So I'm just going to make something that's going through it in some length there. There's my quote-unquote transversal. I don't really want to call it that yet because I don't have my other line, but that's what it will act as in the end. Now I'm going to create a point on the transversal. Now here's an important part, because this point, I can put it anywhere I want, but this point is a point that my line will be going through. So it doesn't matter where, you don't have to measure it off. I'll put it kind of right in the middle right there. Now this point will also act as an angle vertex, because my objective here, the entire aim of what I'm about to do, is I am going to try and create two congruent corresponding angles. Because if I can do that, then that means that I will have made parallel lines. It's the converse of the corresponding angles postulate. So what I'm going to do is say this vertex right here, I'm going to start creating an angle that's congruent to this guy right here. So in order to do that, if you follow the steps, I'm going to start by creating an arc that goes through these two sides right here. With this width, I'm going to go to my new vertex right here, and I'm going to duplicate, here we go, duplicate that arc. Basically big enough that I know that when I draw my other line through here, it definitely creates an intersection point. From there, what I have to do is I have to find out what this width is of between this intersection point and this intersection point. It's going to be important, whoops, it's going to be important because this, I think it's going to be about right there. So that intersection point, though I'll switch this, I'll do it over here. This intersection point, I think it was this one right here, that X, I'm going to go ahead and do right here as well, because that X is where my line will go through. So it's going to go through both this point and this line, and if I did it correctly, or close to correctly, they should be parallel. Now obviously I just used my line tool to make that happen. But the idea is that you use a straight edge, you put it through this point and that point, and you've now created an angle that's congruent to this angle right here. So if I gave numbers, angle 1 is congruent to angle 2, and if that's the case, by the converse of the corresponding angles postulate, then these two lines are parallel. And that's what I just made. I could have also done it, I could have done alternate interior angles, I could have made these guys congruent, done the same thing. But, and you might be asked that at some point to do something like that. But corresponding angles works very perfectly. So it began with me I made a transversal, as you saw, that acts as a transversal now, and I made another corresponding angle that was congruent to that one. Okay, before I start getting into the perpendicular lines ones, let me go back to a slide that's very similar to the slide I made in the first video on basic constructions. It talks about perpendicular lines. Make sure you know what they are. Right there, it makes a right angle. Now, a perpendicular line does not have to bisect a segment, but when we make them, we will be bisecting a segment. So a perpendicular bisector is a line that not only is perpendicular to another line, to a segment, but it also bisects that segment. It divides it into two congruent parts. Now, when I did this in the last video, the difference was when I used my compass, I used the literal endpoints of my segment. This time, we're going to do it on things that might not be the endpoints, and that's how we're able to do, like for instance here, let's say A and B were endpoints. Question is, how do I make a perpendicular line that is not bisecting the segment? Because you might not always want to do it right through that particular spot. You might want to do it anywhere on here. Well, you'll find out how. And you'll do it in two ways. One, we'll do it through a point that's on the line, and then later we'll do it through a point that's not on the line. So doing it with the point on the line, I want to draw something that's going to go perpendicularly through this. I totally missed. But perpendicularly through that. And the only way that it's going to happen is if I can make 2 points that are equidistant from this point right here. So what better way to do it than by using your compass, I ask. And the way that I'm going to do that is, remember that this distance here is a fixed distance. So if I make an arc, just right there. If I make an arc right there, if I make an arc on the other side, just right there. Well, these 2 points here and here are both equidistant from this point right here. So it's like if you took your hand and you covered this part right here, just go ahead and just do that. Just cover that part right there. You doing it? You doing it? Good. If you did that, you're looking at basically a smaller segment right here that is this length. And so these act as endpoints now. So I didn't use this endpoint way out here. I used an endpoint that was very close to the end right there. It's not exactly right there. But these are my 2 new endpoints for where I make my perpendicular bisector. So if you know how to make a perpendicular bisector, then it's like this. Place your pivot on one of your quote-unquote endpoints. Stretch your compass so that it goes a little bit past your quote-unquote midpoint, and draw an arc that goes up and down past the midpoint. Because what you're going to do is go to your next pivot, or your next intersection point, place your pivot on it, keep that width, and you're about to do the same thing. Go up and down. I went down as I said up and vice versa. But what I've now made were intersection points. And these points of intersection are what I'm going to draw my line through using a straight edge. I'll use my line tool. It goes through. And guess what? It also goes, let's do it a little more perfectly. It also goes through my midpoint right there. So what I ended up making was, it ends up being a perpendicular bisector of these 2 points right here. But what I really needed to do was just make it perpendicular to this line, or this segment right here. And notice this point was not the midpoint of this entire segment. So the first part was making sure that I used arcs to make 2 points that are equidistant from the midpoint. And that was very important. Okay, the third one is with a point not on the line. And we're going to do the same thing in terms of, we have to make 2 points that are equidistant from some midpoint that would be going down through here. So let me give you a little theorem, not to prove right now, but let me just give you a theorem. Let's say I already drew my perpendicular line. And let's say I already had my 2 endpoints right here. Those aren't legit, but any point on this line is equidistant to these 2 points. So let's say I drew a segment from here to here and from here to here. These 2 segments are congruent. If I drew it here to here and here to here, these 2 segments are congruent. You might have now found out how to make an isosceles triangle. At any rate, I want to make 2 points that are equidistant from there. And how better to do that than to use my compass and just go ahead and just draw an arc that's going to swoop through this like so. So make an arc that swoops through, and guess what I just made? I mean, I'll let you guess as I'm trying to fix this compass here. I made 2 intersection points, and both of them are not only equidistant from, say, a point down here, but that entire perpendicular line, they're also equidistant from here. Okay. So far so good. Getting near there. Now all I need to do is continue my perpendicular bisector route. But what I don't need to do this time is make an arc that goes through the top, because this point already takes care of that. What I mean by that is all I need to do is go on the bottom side, and I just need to make an arc. Let me shrink this a little bit. I need to make an arc that makes sure it goes through center on this side. Flip it, place my pivot on the other side. I need to make an arc that goes through this side right here. Okay. Now what I ended up doing was making an X that I'll draw my line through. So my line is not only going to go through this point, but it will end up, well, I want to make a line that goes through this point here and that line right there, because it ends up, I guess I didn't do it perfectly, but it ends up being a perpendicular line. And why did I say that I didn't need to do all that extra stuff, like draw on top? Well, because that point already takes care of it. Notice how this thing would have gone through, obviously, but I already have a point on top. It's that original point. Remember, that one already works, so I didn't need this extra part. Not to say you can't use it. Go ahead and use it. But the idea is you've already taken care of what you needed to with this X alone and with that point alone. So the point not on the line, first I had to create two equidistant points right here by using an arc of any length as long as it swoops down and through. Now I use those 2 points to create this X right here, and my line goes through and it becomes perpendicular. Okay, the last one is special quadrilaterals. So here are some definitions of the special types of quadrilaterals that you might see in a geometry class, not including the scalene quadrilateral, where all sides and angles are unique and not congruent to one another. The most unique one is the square, where all angles are right angles and all sides are congruent. The rectangle is like a square, only not all sides are necessarily congruent, just opposite sides are congruent. And by the way, they're parallel. But that's also kind of mentioned by saying all angles are right. But just so you know, in case you're trying to construct some certain things, you can make them parallel. I probably should have said it here as well. And parallel. The parallelogram, opposite sides are congruent and parallel. The rhombus, all sides are congruent, opposite sides are parallel. The kite has two pairs of adjacent sides that are only congruent to, they should say to each other, not to TWO. And then finally I have the trapezoid, where one pair of opposite sides is parallel. And in an isosceles trapezoid, the non-parallel opposite sides are congruent. So I literally read that out loud to you. I didn't want to draw them, so to speak. I think I have a tool that can do all those. Not quite. Oh, here we go. So here's my isosceles trapezoid, for example. I'll just give you one of them. In the isosceles trapezoid, one pair of opposite sides is parallel. And then these two non-parallel sides are congruent to each other. So parallel sides, congruent sides. That's an isosceles trapezoid. I'm going to make two more with you. I'm going to make a parallelogram and a square, and I'm going to do it using this guy right here and using all the other stuff that you talked to, that we had gone over. So use any provided segment lengths to construct these quadrilaterals based on your knowledge of congruent segments and angles and parallel and perpendicular lines. So first I'm going to begin by constructing a parallelogram with side lengths AB and CD. So in order to construct something, you need to start by making a segment. I'm going to make it, because I don't have much room, I'm going to be making it up and down the tall way, this way. In this one, I'm going to make side length AB. So to do that, I have to stretch my compass far enough so I have length AB, as you can see. That's good enough right there. And I'm going to go ahead over here, and I'm going to place my pivot there on this end. That's where A is going to be. And B will be going through right there. So I've now made length AB like so. Now what I have to do is I have to make another line that's going through B right here, that's like this. This length's going to be CD. And for a parallelogram, it doesn't matter what kind of angle this is. It doesn't have to be a right angle or anything like that. So here, let's make this length CD. by shortening up the compass. Yeah, I can't make it perfect. Well, that's definitely not perfect, so we widen it out a little bit. So I can't make it perfect. I'll put it like that. That'll be close enough for what I can do with my software. And let's see if I can kind of get it, though. Unfortunately, this program stuff doesn't always work out the way you want it to because I run out of room. I just wish I could shrink the compass. That's the only problem. There's length CD. Now, I'm going to put a point there. Now, if you remember when we talked about creating parallel lines, before I made a point that it didn't matter how far away it was. This time it did matter. It has to be length CD from here to here. Now what I have to do is make a parallel line. So I can't just say, oh, and then I just draw this down. Obviously I can do that with my software, but I can't just draw it down. I need to make sure it's parallel. So how do I do that? I have to make two congruent angles. So I'm going to go ahead and do this acute angle right down here, this one right here, and I'll copy it right over here. So in order to do that, I have to shrink my compass here, make an arc. Do the same thing over here, place my pivot there and make an arc. Okay, and then I have to find the width between these two intersection points right here. Obviously quite a lot to do with this, right? It's not, oh look, this is already that width, so it looks like I'll be good to go. So with that width, I'll place it, I have to switch this. I'll place it over here. I'll draw my arc right here, and that place is where my line will go through. So you just make another line super duper long, like so, that goes through. Now I have to make sure that this length of this guy is AB. So I'm going to go back up here, parallel. I'm going to go back up here. I'm going to get my length AB, stretch this guy out, whoops, to AB's length. Let's go back up to my point here. I'll place my pivot. Oh man, as much trouble as people have with compasses, looks like I will too. Place my pivot on that point right there, draw my arc, boom, and that becomes the distance from A to B right there. And then I will, and now I'll just connect these 2 points. I don't have to do anything else. Those 2 points are my last 2 points I need. Let's try that one more time though. And boom, right there. So my parallelogram, as you can see, is, I'll make it red before I delete it. It's like that. Lengths AB and CD. Opposite sides are parallel and congruent. And there you are. So it's not called parallelogram ABCD, but the lengths are ABCD. So opposite sides are congruent, like I said. Boom, 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 boom. Opposite sides are parallel. Boom, boom, and boom, boom. So you have to do a little bit of work and then start connecting everything to make it work. It's not too bad. You know, you always got to do some work in math. It's all right. It's kind of fun construction, especially when you get it right. Like when you realize, oh, look, I'm doing this correctly. Like I know what I got to do. Okay, last one I'm going to do is make a square, construct a square with side lengths CD. I had to make sure it was small enough that it could fit everything. Come back here. All right, so to make a square, I'm going to start by just, let's go back to my original line. I'm going to go ahead and make a line segment like that, long enough so that I can make CD from it. Let's go ahead and find that length of CD by bringing this down and shrinking that up. And like I said, CD is not going to be perfect, pretty close to it. So from one end point, or here, you know what, you can create your point of any kind. In fact, that'll probably be better if I do, because I'm going to make perpendicular angles. So here's CD, boom, there's that length. That'll be pretty good to use. Okay, now what I got to do is I have to start making right angles. So from this point right here, let's make a right angle. Let's shrink this down like so. Let's create arcs on both sides of this, one way and the other way. These 2 points right here are equidistant from this point right here. So what I'm going to do is now place the pivot on those 2 points, stretch my compass past the midpoint, and make arcs going up and down. Do it on the other side, place it on this point, and go up and down. And now when I draw a line through here, it's going to be going perpendicularly through there. Perfect. Now what I have to do is length CD once again. So let's go and figure that out. Now I already have length CD up here somewhere, so let's just use this one again. Let's say stretch that out. If this is length CD, then up here this is also length CD. Okay, I'm going to have to do that one more time, the whole perpendicular bisector thing. So let's do that one more time here. I'm going to shrink this up. Again, draw two arcs. So you see there's a little bit of work that needs to be done, but I think we're okay with that. Turn this around, another arc. Those 2 points, once again, are equidistant from this point right here. So let's go and place a pivot on one of those 2 points. Stretch this out a little bit, draw 2 arcs here. Whoa, it's a big one. And, whoops, switch it. And right here, I know it's getting kind of messy. You're like, where's my square? So now I'm going to draw a line that goes through those 2 points right there. It's not perfect, so let me get it a little more perfect. Up and through. Remember, I'm doing, well, it should be going through that point as well. So, whatever's perfect's perfect. Now I have to do length CD one more time. I just have to do it right to figure out the length from here. So length CD, I'm going to have to do right up, I have to flip this around. Right up here. Now I don't have to do another right angle. I have my 2 points for CD here and here. And I'll go ahead and draw my last segment through there. Those 2 points right there. And, you know, whatever, it's as perfect as I can get it, I suppose, right? So if I draw out my square, you can see all sides are congruent. They're all of length CD. And if, well, I can't say it this way, but if 2 angles of a square are right angles, and if these 2 sides are congruent, then the last 2, I'm sorry, if 2 angles of a quadrilateral are right angles, and these 2 sides are congruent, then these 2 also have to be right angles. I suppose that's what I can say. So I know these are right angles for sure. I know these 3 sides are congruent for sure. And when I drew this one down, this one also happened to be congruent to them. And these angles also happen to be right angles. What I could have also done instead of this right angle was I could have reconstructed. Let me move these out of the way. I didn't yet have this line. So I could have found this point and I could have reconstructed this angle using corresponding angles right here and here, and then drawn a parallel line to this. That would have been fine. But just so you get some more right angle practice, there that is. And that's all of it. That's all that you got. Fiend.